Maybe we can give Deborah a couple of more minutes, or I don't know.
Yeah, we'll give her one minute. How do you want to do these? You want to go through some?
Half each.
Half each, yeah.
Who starts and
Sure. Invisible man at the end.
a couple stars. To...
Okay. Hello, everyone. Welcome to the PCE Working Group. I'm John. This is Julien. JP is there in this chair. Before we begin, this is Note Well. I'm sure you've all seen it before, but in case you have not, please take a minute to read it. It's also available online. Tells you about all the rules and regulations that we use to control what people, the submissions people make. Please take a moment to read it if you can. So on the agenda today, actually we have two PCE sessions. The first one is this one right now, which is our usual PCE meeting. The second one is after the cookie break in Charlottenburg, room 2 and 3, and that's the joint Yang session with TEAS and MPLS. So please come to that one as well. Bottom line is after the break, we move rooms, we just go down the corridor, and we're going to have to sign the blue sheets in each session. Before we could begin, do we have any volunteers? I need a volunteer to take some of the minutes. Thanks, my usual minute takers. Are you going to use Etherpad, guys? Yeah, so if anyone else wants to log on to the Etherpad for this session, please do and just help them take the minutes. That would be great. Do we have a JavaScribe?
Only.
Adrian looks really keen to do that. You can
JavaScribe for ourselves.
scribe for each other. Okay. Yeah, that's you. So the usual request, please remember that the people attending this meeting are not necessarily all in this room. Some may be listening remotely. So please only speak using the microphones. Please state your name before you speak so that the minute takers can record what you say. And if you're presenting, please try to stay within this little pink square at the front so that the cameras can pick you up. As usual, just a normal reminder, if you want to present at the meeting, please try to make sure that you've initiated some discussion on the mailing list before you make your request for the meeting so that we have some context and we can see what priority to give to each request. That would be great. Thank you. So here is the agenda for our first session. Does anybody want to bash this agenda? Okay. Daniel Bash.
Daniel King. So unfortunately, nothing I want to change on the agenda, but just to let you know that we've got a problem with Meet Echo at the moment, so we're having to email the team trying to resolve that. So that's maybe why there's no one in the lounge.
Okay, thank you. You want to take it?
Okay. So since the previous meeting, we have two new RSC published. So one is the IRO update to clarify the use of the IRO object within PCEP. Related to that, the use of the domain subobject within PCEP for interdomain applications. So both were published for a couple of weeks. So thanks to everyone who worked, including John, who's been working hardly on those, on Drew, who was the editor of both. We have one requested publication, also edited by Drew in the pipe. So I think it should be published quite soon. We have several code point allocations. So one I just started for the stateful draft. As you may know, we already had some collision with some of the code points used there because of the implementation already shipping in the operational fields. So we have started a process for requesting code points from the INA on those. And just lately, the code points were requested last year for LSP setup type and segment routing have been renewed, but please be aware that this is the last renewal option, so those drafts need to progress soon. And I see Jeff coming to the mic. Yes, Jeff, please.
So with regards to segment routing draft, we'll start discussion among authors. The IGP and the GPLS draft has different semantics for MSD of 0. And I think after we have agreed, we could go into last call. It's been stable, the implementations.
Okay, which is good news because it seems to fit within the 1 year period.
Thank you.
Okay. We have a recent discussion about the PCEP secure PCEP draft, the PCEP-S, related to its type of document. It was upgraded from experimental, if I remember correctly, up to standard track. There's been some emails over the list. I think this point is almost concluded. I see Ruth coming to the mic. Yeah.
Hi, this is Dhruv from Huawei. So regarding this, among the authors, we had a discussion, and because we have implementation as well, which we in fact wrote during the IETF hackathon, trying to use TLS on owners as well as the Telefonica's version of PCEP security. So we feel that this document is better suited now for standard stack, and we asked the working group as well. We did not receive any negative feedback on that. And apart from that, all the other comments are also handled. And we were actually waiting for the stateful PCE code point. Once that is done, I think this can also directly be pushed to for the last call. In fact, already done. So we just need to send to the.
And we don't feel we need another last call just for this slight change. The decision has been made clear on the list already. So it's probably the version that will be pushed up to the IESG.
Thank you.
We have a draft which has been updated recently after Shepherd review, which was done about the PC applicability. We have 2 reviews in progress about the. Oh, I see John coming about the applicability, I guess, of the stateful PC.
Actually, about the synchronization optimization, I think we already received the Shepherd's review comments and we updated. Oh, that's not actually.
No, that's right. The stateful sync optimizations has had a Shepherd's review already. It's done. I don't want to push it to the IESG until we push the base stateful draft because it doesn't make sense to go out of order.
But here it says Shepherd's review about to be sent.
No, it's done.
Oh, okay.
Yeah, it should have been on the other part of the slide. You're right. So the PC initiated has been discussed with one of the editor this week, and we're about to share publicly the latest comments. I think apart from the one discussed this week, only needs will remain, so it should be just some editing stuff. We have one waiting SharePoint review, which is the all GMPLS extension within PCEP, which is probably going to be the next big move to clean up all our queue of working group drafts. We also have some smaller drafts, but which have been there for a while, which are interlayer extension in PCEP and WSON in PCEP2 extensions. So both seems ready for last call. So there will probably start it after IETF, one after another, I guess. So make sure to leave some time during summer to people to read and send feedback. Those are part of the former one we want to get rid of and push to the IG within a reasonable amount of time. So now we have the working group draft. Some are pending status. So on the latest one about segment routing on this list, we already had Jeff sending some feedback, so I don't think we need to repeat it.
And LSP setup type will go with it because they're interconnected.
Okay, so you consider post-share fate and will be progressed soon, which is good news. We have the couple of ideas related to the stateful GMPLS things. I'm looking at Tian, who's probably aware.
And I'm a co-source for both the first two drafts. I think from our point of view, we think it's ready, but we would like to see more reviews. If you're interested, please review the drafts and see if you have any comments. Yeah.
So I hope everyone has heard. You may also use the list to share that proposal to be sure that anyone who's not in the room is aware of that step and make sure it triggers interest or captures some time of people following the list. Thanks. I think we're done with the introduction. So we're going to move to the first presentation on the agenda, and I think it's Dan who's going to talk about housekeeping again, because post-draft you're going to talk about I've been there for a while. Now it's time to move on. Here you go.
A while. It's relative, right?
Always.
Cool. Yes. So kind of a mea culpa actually, because both of these documents have kind of sat in the PC working group for quite a while. But I have good reasons. I have one good reason at least for the hierarchical PC extensions document. The document's actually been relatively stable for at least a year, and the hesitation to kind of move the work forward really was dependent on implementation feedback and experience. And the first implementation that we had of the hierarchical PC extensions was directly related to a European project, an academic project that we were working on, and we were just kind of waiting for some of the vendors to kind of catch up. So if you read the latest version of the document, 06, I think, then you'll see the write-up for the implementations, the experiments that we performed using hierarchical PCE. If you are a vendor and you have been investigating, or you have implemented, or you are indeed selling product that actually has, if not some or all of the capability described in the document, then please let the authors know so we can kind of tag that as another potential implementation. So if you take a look at the most recent version of the document, it's really just making sure that we've got the correct format, and we've for the IANA section, making sure that we've got sort of all our values correct. We looked at the manageability, the security aspects in a little bit more detail, thinking about as you implement, what are the considerations that you need to make. One sort of kind of big change potentially is the document was originally experimental. We felt, the authors felt that considering the three implementations that we now have, we would like to see this progressed as standards track rather than experimental. So that's kind of a question for the chairs.
I'm sure you have anticipated that the chairs are going to look at the working group about that.
Yeah.
I don't have any strong opinion against, especially as you come with multiple implementation, having interworking already happening. So does anyone in working group has a view on that? It's similar to the PCEPS case that we have before, which got upgraded to standard track 2. So it makes sense to consider the same for this. So if no one wants to come on lively during the session, I think we can go to the list to ask if anyone is opposed to that change. If no one's opposed, we'll upgrade.
Okay, cool. So we'll wait for that on the list. So
Yeah.
any objections?
We can handle that point if
Yeah.
you prefer, yeah.
Great, excellent. And just a final comment here, sort of hierarchical PC will become, it is now being put into the code base at sort of a near future release of Honest as well, which is, oh no, another controller. Okay, yeah, I think that's kind of everything. Again, it would be nice to have vendors kind of look at the latest set of encoding schema that we've got for hierarchical PC and make sure that the values and the error handling that we've got is sufficient as well. So any questions? Okay, so either the document's perfect or no one cares. That's either way. Second document, really have kind of no excuse here actually. This is a piece of work that must have started back in 2012. It was, at the time, we felt we needed an informational document that would describe how you might take some of the capabilities of PC or PCIP and combine them to deploy into AS, into area services. A cookbook, if you like. You know, we had a lot of protocol function, how you would use that for the different use cases, what kind of considerations might you make. And it collected a number of authors. Each author was responsible for kind of either a particular use case or a particular area of interest around sort of management of things like the traffic engineering database or a particular PC architecture like hierarchical PC or using a particular method or heuristic for path computation. And it's actually kind of working on the document over the last few weeks. I still think it's a really useful document. It doesn't suggest or make any kind of requirement for new extensions or functions or code. It simply states what we have and how you can use it. So anyone kind of coming to the PC, to the working group and kind of thinking about, well, how might I use PCE architecture, what protocol extensions do I have for a particular type of environment, sort of inter-area AS, packet, some optical applicability as well. So we've got some discussion on ASON in the document as well, and thanks to the ITU guys and some of the folks from the OAF for that. And sort of the recent, it was kind of worth waiting a little bit to add some of the recent documents that we had for things like managing the database, computing domain connectivity. So I think now, though, it's time to kind of close the document. If we want something that talks about a PCE document that describes how you might use remote initiated PCE or stateful PCE, and some of the other kind of cool technology that's coming through the pipe, well, we can wait. We'll just kind of leave those for the documents to stabilize and be published as an RFC and have maybe in a year's time or 2 years' time decide if that's something we want to have in like another cookbook for some of that type of function. So none of you would have read the document because I only posted the new version at 12 a.m. last night. So again, kind of apologies, making lots of apologies this afternoon. But if you can take a look at the document, send me any comments, suggestions. A big thank you to Dhruv actually for doing a very kind of exhaustive review. I think we can sort of wait and then but look to last call certainly way before IETF 97, preferably. But I don't expect to have too many comments.
So thanks, Dan, for staying up late last night and getting this in. It's much appreciated, and also thanks, Drew, for following through on the request and delivering that review. That was really helpful. So yeah, the message is received. I think we can move this to last call soon after the meeting. Yeah.
So I think next presenter is Xiang. Again, another old draft that we want to move back again.
Good afternoon, everyone. My name is Xian from Huawei. I'm presenting the draft, the PSAP extension for enhanced error. So, this draft was not updated since 2012. So it was this time we revived it because personally I think it may be useful for the hierarchical PCE, also maybe the multi-domain PCE case, and because it's not updated for a while, so I want to just describe a bit what actually this draft talks about. So it actually identify as well as classify the possible PSAP behaviors in case of errors and the notification. And it also proposing extensions to the PSAP in order to allow the PC to have ensured, or we say predefined behavior. Here it shows what a bit of what the draft has. So on the left-hand side, it actually classifies the behaviors. In case of for example, the error, depending on whether the error is propagated or whether it is what is the criticality value, we classify them into 6 types. And in case of a notification, also 2 criteria where we have 4 types. So on top of that, there are 2 objects proposed. First one is the time to live object, where you limit number of PSAP peers you're going to propagate this message. Another one is the diffusion list object, which you actually specify the specific list of peers you want to advertise or say propagate this message. There's quite 2 chapters talking about how these rules apply to the existing RFCs. Like for example, we have 5440 for the PSAP, the base PSAP, stateless PSAP extension. We also have the 5441. They describe the error and the notification. And so there's a chapter which actually talks about how the rules, the classifier mentioned the 6 types of errors and 4 types of notification apply to those scenarios. And in the end, it also gives examples for each type of, not every single one of them, but most of them, the types. And it provides an explanation how this belongs to which type. What I did is I reviewed the whole content. To me, it's technically sound. So my major effort is actually trying to make it read better. So for example, I restructured some of the sections because it's not as clear when I read it. And also, I add a table, as you see in the previous slide, that I make it simplified, so you know that's error type 1, which was not there before, because they are combining the 2 kind of criteria and put them together. It's a long name, so I'm shortening them so it's easier for people to understand when they read it. And also, I did a bit of proofreading, like tidy up the RFC 2119 language. They used might, which we actually used may. Also resolved a couple of to-do items they put in the draft. So there's still some work planned. First of all is the scenario section. There's some work I expected because there's one scenario I think they interpreted wrong, so I need to probably clarify that. And I also plan to do a final check on the security, manageability, and the IONA section. If anyone wants to volunteer for the section for the security and manageability, I'm more than happy to hand that over. And I hope we can get the WLASCO in a couple of meetings. If not next, maybe the first one next year. I know this draft is not active for a while, so I would really encourage whoever is interested, try to review if you have not done before, or you have done before, but you maybe have posted some comments. Please to check whether it's already get resolved or not. Yeah, thank you.
I drove from Huawei. I in fact went back and found the IETF 78 when this was presented and discussed during the adoption. And some of the things now time has passed and way we are using PCE has also changed a little bit. This was from the time when we were thinking of using PCE monitoring and having a PCE sequence. So we do need to send the notification back. And in fact, the PCE knew that there is other PCs in the network in the whole chain. But we have actually deployed it. We have moved towards maybe using things like domain sequence and hiding the whole sequence of PCE. So we may have to step back just a tiny bit and reevaluate whether we need to really propagate all these errors and notifications back to all the PCEs. And if we do that, we need to make it technically sound as well, because I think the TTL and the DLOs have some issues and they may lead to this thing. So that's just my suggestion to you. And thank you for doing this and taking up this work.
Okay, I see one of the courses is coming up.
Mike, I don't know if you want to give some answer.
I discussed with Jove offline. I think, yeah, I would like to hear other people's opinion whether this thing is useful. So for me, it's it. But for Jove, it's maybe need to investigate a bit before we decide, I think.
Yeah, but I think it is right. We need to evaluate the actual need based on our current work. But it doesn't mean that past work has vanished. So both are legitimate, but as Xiang was mentioning, hierarchical PC use cases, stateful PC use cases, maybe bringing some new requirement there. And now is the time to consider them and put them into the document. And that's why she's considering only a couple of IETF before moving to LASCO, because we know that there is some new work there that needs to be integrated. So you're very welcome to join and propose.
It's useful work. Would be also good to produce some guideline, because there's huge amount of drafts and they behave differently, they signal differently, and would be good to have some alignment guideline for future drafts, how to deal in particular situations.
So thank you, Jen. And hidden in Jen's presentation there was also two requests, one for help with the security and manageability sections. If you feel you're particularly adept at writing sections on security and manageability, then Jen would really appreciate your help to write some text for those. And also a request for review and input, whether these scenarios are still relevant or if we should take the document in a different direction. Please send your comments to the list so that we know where to take the document the next time.
So we are moving to the BGP-based PC discovery mechanism by Jay.
Good afternoon, everyone. I'm Jae-dong from Huawei. And this BGP-based PC discovery mechanism was presented last year. And since then, we have two updated versions here just to introduce the updates in this draft. Okay, a little brief recap about the motivation of this draft. We know that for PCCs and PCEs, they all need to discover automatically the addresses and the characteristics of the PCEs they want to connect it to. And in several use cases, the IGP-based discovery mechanism cannot be directly applicable because the PC do not participate in the IGP directly. This including the cooperative interdomain PCE and also the hierarchical PCE scenario. And when the BGP-RS is used as the mechanism to collect the topology and routing information from the network. And recently, we also add another use case, which is the PCE for the VPN path computation use case, which is contributed by our new co-authors. And so if the BGP-RS is already used for the routing information collection, we can reuse this BGP session for the PCE discovery. So here is the overview of this mechanism. Basically, the PCE information will be provided to the BGP speaker. Maybe it is co-located with the PCE, or there is a link in the same network. And then the BGP speaker will use the BGP-RS to discover this PCE discovery information through the network. Of course, this will be compliant to the policy of the user operator of this network. What I want to mention is this kind of BGP-based discovery information may be redistributed into the IGP through the IGP-based extensions. But this is a kind of out of scope of this draft. So here are the updates in the version 04. In this version, we improved the description of the use cases about the PCE-based discovery. And we also clarified the protocol ID field in the BGP-RS NRI, which can be either the direct or static configuration. Also, we improved the operational consideration to mention that the operator can use their policy to control the distribution among the ASs. And some editorial changes are made in this version. And in the 05 version, we added the use case of PCE discovery for the VPN case. And we also specify that the address family used for the public network scenario and also the VPN scenario. Of course, we add the new co-authors and the contributors who contributed this new use case. So this is a simple example of this PCE discovery for the VPN case. We can see that the PCC is located in the VPN site, which may require the end-to-end C2C path computation, but the PCE may be located in another VPN site. So in this case, we need a BGP-based discovery to distribute this VPN per VPN PCE information through the network to the other VPN sites. So here the conclusions is we think that the BGP-RS-based PCE discovery is useful in many use cases. And some operators show their interest and they're getting involved in this work. And draft now is getting stable. So at this time, we would like to ask for the working group adoption of this draft. Any comments?
Okay, so who has read this draft? Hands up. And who would like to see this get adopted by the working group? Okay, so a few hands went up. Maybe more the first time. Yeah. Okay, I guess we take the questions to the list.
Okay, thank you.
So I think next presenter is Drew. Draft.
Hi, I'm Dhruv from Huawei. Okay, let me turn this a little bit. Okay, so this is has been discussed in the mailing list for a while, and thanks for the comments for this. This is basically we look at our PCEP INA section, and which does not have any experimental code points allocated. So this is our aim that if we can have some experimental code point allocated, how would that work? And also discuss, consolidate where we are in the mailing list and what are the open questions that we have for the working group where we need more feedback. So our PSIP registry is right there. Its allocation policy everywhere is IETF consensus. That means we need an RFC published, and ISG needs to approve that RFC, whether it's from working group or whether it is AD sponsored, etc. So, but now we are realizing that we need some experimental code points, especially when we are starting working on open source, and our speed of development is not at par with the speed of standardization. Even with early allocation, we have issues. In the past PC working group, we have also had to write a BIS document because of this. So we do want to fix this problem once for all. And allocating some experimental code points separately would make sure that we don't run into any of this problem for current as well as future allocation. So this is what's there in the current draft, at least in the normative section. We are only talking about 3 things right now, which is messages, objects, and the TLVs. And this is the range that we agreed on as per as what's there in the mailing list. Around 8 code points for messages, 31 for objects, and around 255 from TLVs. There was a suggestion from Ramon that TLVs, like if we look at what are the current experimentations and other documents that's there in the working group, the number of TLVs may be a little high. So, and since we have space, is it worthwhile increasing it to 511? So that's one question that is still open to the working group. Right now, the authors feel that the 255, 31, and 8 are good enough numbers, but we want more feedback from the working group if it needs to be increased. And of course, the rest depends on what the ISG and the INR and other people think what we are doing is right or wrong. So this is where the document is right now. Now, I'll cover the allocation policy as well. So when we do it from the experimental code space, the allocation policy will be experimental. That means INR will not record what this code point does. So where do we record this? We can start recording in PC working group wiki. I have already created a section in that wiki where we can start adding any of the code points that we need, especially when we start interrupting between our controllers or this thing. It's better we use the same code point when we are doing it, and we don't want to mention that code point in our draft and lead to all the confusion. So it will only be maintained in the wiki. And as the documents progresses, and if it matures and it gets an early allocation or publish in RFCs, we will remove that from the list, and every implementation is expected to anyway use the standard code point. It doesn't need the experimental code points from the past. So this is the process that we could follow and make sure that things run smoothly. So after that, Ramon basically commented that why are we stopping at this level? Do we need to start looking at the whole PSEP INA and figuring out what are the other things we can do and make sure that we do it correctly? So what we did was divided our PSEP INA registry into this around 5 categories. So essentials, which are already there in the document, some other things which are good to have and quite simple to add as well. So example being error types and notification, and maybe reason to close a PSEP session, a new metric type if I want to experiment with that, and no path object reason. So these are pretty straightforward to add, and we can start working on this if the working group thinks that's a good idea. The things where we think it will get complicated is when we have cross-registry, which is all our sub-objects, which is cross-registries within the PSEP document as well as with the RSVPTE code points. And we think that this is something, if I want to experiment, I can encode this in a vendor-specific object. I can do it by some other way without having to change my whole implementation. So this cross-registry is something, at least from our opinion, we can ignore. Luckily, and the second is already exist. OF codes already have a private space, so experiments can anyway use them. there are no issues. With flag fields, we feel we should not allocate any flags for experiments. If somebody wants to put a flag, he should create a TLV, put the flags inside the TLV rather than directly using the flag of the objects, which will make sure that we don't run into any issues while we run any experiments. So this is what is there in the appendix of the document, and we have putting our suggestions, and we are looking for feedback on how to handle. One issue is specific to error and notification types. Since we have error types, from error types, we can definitely allocate around 224 to 225, say, code points. So these are all new errors. And of course, all the error values associated with them are also of experimental range. But what do we do of error types that already exist? For example, invalid object. Should I also say that for unknown object, I say that, oh, let me, for all existing error types, let me also give some experimentation aside. This could be, it's possible. And in future, any new error types anyway can follow the same guideline and allocate some code points separately. But we want to know, is this useful? So people who are writing new drafts and who would be experimenting with their drafts, and most of the time when we write the draft, we try to use the same error types if it exists and ask for a new code point when we use the error value. So it has its value, but it will increase the, it's not too much work, we can do it. But we want to know the opinion of the working group. Yes, this is could be useful. And the same apply for notification type as well. So in conclusion, is this useful? We think so. We got good feedback from the working group as well. And second, should we expand our scope? And our suggestion is we expand our scope by adding these easy to add and good to have. All of them have good use cases. We can think of experiments and even drafts that exist right now, which are defining some of these. So we feel this could be useful, and ignore the rest. And because we know that we can handle this, we can experiment with these cases by some other way. So this is our suggestion, and we want to know whether the working group agrees with this. And that's it. And if the work is straightforward, let's adopt and let's do this quickly. Thank you.
Hi, I'm not Lou Berger. I'm Adrian Farrell. Do this, adopt it. But I don't think it's quite right yet.
Okay.
I believe we can adopt and tweak it inside the working group, and that would actually probably send a better message. You're quite right, experimental in a closed environment. One of the reasons why experimental spaces are normally quite small is to actually force people to recognize that they have to either get a code point or let go. And in particular, in the context of open source, I'm really worried about a header file that's got a value in it out of the experimental range, which is, you have to have that to build the code, but then the open source becomes a release, and suddenly that code point is stolen out of the experimental space and is a real, if you like, squatted code point in the field.
I agree with you. This could be a problem. One case we were thinking that, like what we do with early allocation, do you think we can apply some policy within our wiki page of sorts that whoever is adding this code point has to give us a reference, give us who's the responsible person, where is the draft which describes this, and then you have, say, 3 years or 4 years or 5 years, some numbers that we figure it out, and after that, sorry, like if you haven't standardized this or moved your document for so long, maybe this experiment is not going anywhere, and we can think it. So what's your suggestion?
So, well, I mean, what you just described sounded like an early allocation, and we pay IANA millions of dollars a week to run the registries. So they should, if we need registers of code points, let's work out how to put it in IANA. The flip side is experimental. The point is that you don't keep a record across experiments, because The experiment is the deployment, the experimental network. And then when you run an experiment, you look at the list of code points you need from various different things you're running and just do it there. It may be that the open source thing is pushing us to something that is neither experimental nor early allocation, in which case we should not try to solve it with experimental or early allocation. We should think about a third way. I don't know what that is.
I have a third and fourth. Lou Berger. So I came up here to make a different point, but I'll make this one. So there's actually two different allocation policies you can use to achieve what you've just talked about. So if there's the case where there's someone out there, they want to use a code point, it's likely to be used by them for a little while, maybe years, and we don't know how long. You can do that with, I'm forgetting the name, but it's like specification exists. And what's a specification? A specification is something published as an RFC, but it also could be a externally referenceable document. So if there's an organization out there and they say, hey, we have this cool new thing we want to do and we're going to define it, and here's our document, it's a PDF, text file, HTML file, and they publish it, they can ask for, if you have the right policy, they can go say, hey, give us a code point, and you say sure, and that's a stable reference. So that's one way of doing it.
Look, but that's for when it's actually stable. This is
It doesn't say that. It doesn't say that.
Okay.
Early allocation says that. Early allocation says it has to be stable. Specification exists, doesn't say it has to be stable.
When I read the 5226, if that's the right number of the RFC, I saw my options were private use or experimentation. And since this is
specification exists also.
okay,
We
I will
moved
recheck.
over in T's to actually use that for everything.
Okay.
And the only thing that it confuses the ISG every time we say standard or specification exists, and they always go, yeah, but a standard is a specification. It's like, yeah, but we want to call it out because we have different review rules for it. So that was one option. Another option is if you want to do, Adrian's going to give me the right term. If you want to do the thing you're talking about of managing your own code points on the wiki, because it's a temporary thing,
Yes.
and you want it to be fast moving, there's another allocation policy called reserved. So you can go and reserve a block and say reserved for use by the working group. And you, what?
I think Adrian can correct. I think we don't have that anymore.
What do you mean you don't have it anymore?
Adrian, you have the laptop in front of you. You can.
Adrian Farrell. Well, yeah, so in a former life, I used to be an AD, and reserved does not exist.
It
It's
used to.
not no, it never did. It's not an allocation policy. There is talk about putting something in 5226 bis, which mentions that you can reserve, and reserved in 5226 bis means unavailable for allocation by anyone. Furthermore, specification required requires the existence of a document that is permanent and readily available for public access.
Right. What's really cool is we all have these little devices now. So while I didn't have it, I can now quote RFC 5226, reserved, not to be assigned. Reserved values are held for special uses. Hey, a working group using it they want, that's a special use. So if you want, go down that path. You can see whether or not you can get it through the ISG, but you can say reserved. These are not experimental. This is for use by the working group, and the working group's going to manage it.
But what's
And
the
that's your
benefit?
wiki. What?
What's the benefit of
Because
using
an
reserve
experiment is a
versus?
specific experiment. What you're talking about is not applicable for experiment. What you're saying is, I'm going to use it for experiment 1, 2, 3, 4, 5, but I'm going to allocate it once. That's not experiment. An experiment is a specific activity.
No,
For-
what we are using working group wiki is only for coordination. So if experiment 1 wants to use the same value, experiment 2 wants to use the same value, they can still use it. But if they want to work together, they come to the wiki and
That's an IANA function. Go to IANA, get it done.
okay.
But you're saying you don't like the experimental definition. There's another definition called reserved according to 5226.
Okay.
Okay, in any case, it
So-
seems that we all are agreeing on the intent. We are
No, this is-
disagreeing on the exact process, on the exact words to use. So I would like to see that discussion happening on the list with the right reference to be available to everyone. and make sure that we can all look at the right RFCs to agree on the terminology and this associated process. I'd like to leave the floor to other people queuing there.
Could I come up and make the comment I actually meant to make?
Very brief one.
I'm very concerned about having this informal allocation mechanism for any type of value that shows up in multiple protocols. That causes me huge concern.
We are not doing multiple protocols.
I heard you say that you're going to have values.
We specifically said here we are going to exclude that from this work. That is the reason we gave that we don't want to do this. So we will only limit to this part. Sorry, this part, and this part is completely out of scope.
Okay.
Don't take it. By the way, if I may, just before John joins the queue, that's why I like focusing on the very first row. As you say, you can encode many things in your own messages, main object, or any objects, any TLVs. Extending too much may leave too much space for people to have experiments looking like final releases. Why we want to have experimental things, implementation, being able to interwork together, but not consider this as a final release. So that's why focusing on the very left row might be enough from my chair perspective. That's my personal view.
That was our original intention, actually.
But we'll back to the mic. Thanks.
John Hardwick. So yeah, I think irrespective of the point Lou made, I still think I would like to see an experimental code point registry. I kind of came up here to make a similar point to Lou, but I didn't like the idea of having those things recorded on an official wiki that makes it look like actually we're having our own registry. So I think we should look at that and probably not do it.
Okay.
In terms of what we should apply this to, just speaking pragmatically, a lot of the drafts I've looked at recently have been squatting on error code points and notification types. So I think error type and notification type could potentially be useful to put in that first column. The others I'm not really very interested in seeing, but so if all we have is the leftmost column, then that's great. If we could squeeze notification and error type in there as well, I think that would be fine. I don't want to go as far as saying reserved error values.
Yeah.
I don't think there's a.
Do you have a preference in this too? Just since you are there, between the two values, whether we should assign error types for already existing error types? Like
no, I don't think we should reserve error values
right?
within existing error types.
Yeah.
We should,
Thank you.
If we do anything at all with error types, it should just be error types.
Okay, thank you.
Hi, my name is Michael Scharf, and I'm speaking here as a TCPM co-chair, which might be a surprise to you, but actually we had 2 or 3 years ago a very similar problem with TCP options, because this is exactly the same thing as experimentation. And we had similar ideas like this here with wikis and mailing lists, and we didn't manage to get this through the ISG. So, and by that time we learned that IANA has very flexible tools for this. So I'd like to back a lot what has been said here on IANA. And as I said, as we started with similar ideas and we ended up with an RFC that has a registry in IANA, I recommend to look at RFC 6994. That's the solution that we came up with in TCPM. I don't know whether it applies to all of these problems, but as I said, this is what we ended up with when it hit the ISG. And I would expect that some of the concerns that we faced would here apply as well. So the RFC is 6994.
I'll look through it. It's in the minutes, right? Yeah.
Okay, thank you all. Do you want to conclude? Or
so I think I'll take up this suggestion. We'll put out a new version as well and ask for review. And I think after that, on the version where we have handled all this, it's better. That's when we call for adoption.
may we see a show of hands of people who read that draft? Among those who believe this is a good work to progress? Well, not as much, but a big subpart, I guess. Thank you.
Thank you.
So, Ruth, I think you next presenter again.
Okay. So this is about applicability of PC and PCEP protocol in ACTN. So ACTN was just discussed in the previous T's session, we went through the requirements and the information model as well as the framework. So this is basically the ACTN framework that you see in front of you. It has a hierarchy of controllers. It has some 4 main functions. We will discuss those 4 main functions and see which part PC can play and how. So the 4 functions are multi-domain coordination, abstraction, virtualization, mapping with customer request and the real network, and virtual service coordination functions. So basically the work in TEAS is progressing. The documents are working group documents, both the requirements and framework. So we ask ourselves as a PC working group what PC can offer. We know PC is the key function in any controller. We have stateful PCE, we have PC initiation capability. We also have a document which talks about what role that PC plays in ABNO. And now in TEAS, we have PC-based central control. So all these works are ongoing. We also have past work with multi-domain and multi-layer, per domain path computation, BRPC, HPC, and also stateful HPC. So this is where we are in PC. Now we'll try to see if how do we map the PCE to the various architectural considerations that the ACTN framework talks about. So the first one says multi-domain coordination, where its aim is that MDSC somehow overviews different domains and build end-to-end networks, network topology, and coordinate path setup end-to-end. So which sounds very much like what we have in the stateful HPCE. We use the stateful PCE with initiation capability. You have a parent PCE sending PC initiate messages and getting the report and setting up end-to-end paths. So that's exactly what we do in the stateful HPCE. We have slides that will talk about it in detail. Next, we are talking about getting information. That is, how do we build multi-domain topology at MDSC? It could be full, it could be completely hidden, or it could be something in between. So how do we do abstracted view of underlying domains? That's where we have a proposal. Of course, BGP-LS is equally applicable there, but within the PCEP context, PCEP-LS is another proposal where we have worked on adding information about marking that the topology is actually abstracted, or if it is attached to which VN construct. So those extensions are also in place for PCEP-LS. And another benefit is PCEP-LS in optical networks. We were hoping that we will get better traction. That's one of the use cases that we have for PCEP-LS. So another function, customer mapping. Again, stateful HPC, you have an initiate, maybe a Yang API or RPC or configuration on the controller, which is the customer view. You break it down into what exactly needs to be told to each domain controller. Mapping function. Again, stateful HPC can do that role. And then the coordination function between various customers. That's where the VN association draft that was presented last IETF. Again, very straightforward work. So this is basic. The idea behind this presentation was to show how the PCEP architecture as well as the various extensions of PCEP comes together within the terms of ACTN and how the mapping is being done. So we'll start with first one, which is stateful HPC. So which was also discussed in the last IETF meeting, and it's basically it's an informational document which just says that we already have HPCE, we already have stateful PCE in a hierarchy of controllers. If both parent and child PCE are stateful PCE, how would that work? It's that there are no new extensions that are needed. Your HPC extensions and stateful PC extensions are good enough to make this hierarchy work. So, so what does this document explains? This document focused on how are your process changing and what is the relationship and the message exchange that might happen between the parent PC and the child PC. It has various cases because we can set up end-to-end LSP. There are various modes in which HPC can run. So document talks about multiple of them, but in the ACTN context, the per domain LSPs is the one which makes a lot of sense. With the idea being, I get a requirement that these are two endpoints. I calculate end-to-end path either with the help of my parent PC, with the help of child PCs, or because I already have the abstracted topology, and use that information to find a path. Break them down into the paths that needs to be established in each domain, set up those paths, get the information with using PC report. Are the paths established? Only if every segment is up, then you can consider your end-to-end LSP as up. So, and of course, you need to stitch it via some mechanism. So this is stateful HPC. We can see how this fits into parent PC being MDSC, each of the child PC being PNC, and the model and the protocol and the extensions apply as it is, and can be used to get the requirements of ACTM. The second one was, this is also presented in the last meeting, which was VN association. So when we are establishing multiple PC initiated LSP and we are sending multiple messages, it will be useful to associate them to the customer mapping, which is the VN name. So using the VN name at MDSC, passing it on and associating the each LSPs with a particular VN association ID, that's the concept. Using the generic association object, you just need a new type, and you can maintain that mapping between the customers and the LSPs at the PNC layer as well. And you can use this for some optimization, etc. We also had PCEP-LS, which was discussed in TEAS as well as in the PC working group. And I think there are some more presentations in later which sort of reference almost the same idea. So what is this? Using PCEP itself to carry link state and traffic engineering information between any PCEP speakers. It includes nodes, links, prefix, also the TE data that is attached to that. The information could be whatever we want to send. It could be full topology. It could be only local information from the node. It could be from parent PC to child PCE. So between any PCEP speakers, this is just a protocol. So where you run it and what information you want to send is all flexible. So PCEP-LS will allow you to use it in whichever scenario you see fit. Whether you want to only send border nodes and inter-domain links, or you want to send abstract topology, full topology, and also you can tag it with the VN, for which VN, if you are creating an abstract topology for a particular VN, you can also tag it with VN. So this is where we are with PCEP-LS. So we talked about, just to summarize, the three different extensions, how they are fitting it into the ACTN architecture. So let's bring everything together and see, just run through how does this work? Let's talk about the various operations that are there in the ACTN framework document and see how PCEP fits in. So the first is we need to build the topology at MDSC. Suppose we use PCEP-LS and get the topology. It could be abstracted topology in this case. In one case, it is just boundary nodes. In another case, there are some abstracted nodes. So depends upon each PCE what topology he would like to expose to the parent PCE. Or it could be simple HPC model where we hide all the information of within each child PCE. So that's the first step. The second step, I would like to instantiate a particular VN. So you need to identify what are the boundary nodes and what are the endpoints. And once you have the endpoints, you basically have what we call it in the info model as a VN member. So in this case, we have two VN members set up a path from A to F as well as to A to I. So the PCE or MDSC in this case needs to compute the path. It can use whichever path computation logic, whether he needs to use request and reply messages and get it from each child PC, use the normal HPC path computation technique, or since he has the abstracted topology from this and he wants to rely on this information, he can do that. So based on that, from the protocol point of view, he just needs to break it into per domain LSPs and send messages to each of the child PC to set up those LSPs, and this is where the PC initiate message can play that role of VN instantiation. What we need next is we need to know what happened to this VN instantiation. We have report message, and the report message from each child PC can be propagated to parent PCE as a part of stateful HPC architecture. And once we have these report messages from each of the child PCs, we know that our end-to-end LSPs are up. If there is a status down, if something goes wrong, the MDSC or parent PC has that information and can react to this correctly. So that's where the per domain report comes into picture. Next is if there's a change from the customer, again, we get the update, map it to the exact change that needs to be made in each domain, use PC update message, or in fact, we may need to tear down an old LSP and set up a new LSP. So we can use PC initiate with R flag or PC initiate, make changes. We have those messages anyway. So we will use those messages to set it up. So this is VN modify. VN delete, okay, no more requirements, delete everything that I had created, turn it down. We know how to do that. So why we wrote this document? I think John, last time when we were presenting the stateful HPC and the VN association, asked that if we would have how these various pieces that we have within PCEP are coming together and see them in one place would help the working group in figuring out how this PCEP work fits into the ACTN framework. So that's why we wrote this document, and we want to know whether the working group agrees what we have written. Does this hierarchy of stateful PCEs applicable to the ACTN framework? Second question is the protocol. PCS function is fine, but what about the PCEP protocol? What we care about in this working group are the messages that we already have, report, update, initiate, works well in the context of ACTN. So is PCEP a good candidate for this interface? And then whether this document is actually needed, is this document helpful in seeing how the pieces are coming together? So these are the questions that I have for the room and want to know what people's opinion. Thank you.
Anyone else at the mic? I see John's coming.
Yeah, so thank you, Dhruv. Yeah, it is my fault you had to write this doc. So yeah, it's useful to me because I've learned a lot about ACTM, so that's good. I'm just trying to put what I know now together into a big picture. So from what I understood, ACTN is intrinsically hierarchical, like you have this NDSC in the middle, which is like a parent PCE, and then you have the PNCs, is that the right term? Yeah. Down at the bottom of the chart. So HPCE is pretty much unavoidably an intrinsic part of ACTM. Then we have the VN association, which again seems fairly fundamental to the whole ACTM problem. I'm not sure on VN association. I've not yet understood why the PNCs need to know the VN association for the LSPs they're setting up. I haven't been given any, I mean, I'm sure there must be a reason, but I haven't been given any information about what they're going to do with that association. It seemed like it was just something that would exist between the MDSC and whatever sits on top of it. So it would be helpful to have a bit more understanding there.
Okay.
And then the third thing you mentioned was PCEP LS, and I was not totally clear whether PCEP LS is an intrinsic part of ACTN or if it's just something that might fit with an ACTN, but there are other ways also of doing it. So
yeah, so I agree with you. There are always other options, and PCEP LS, we just wanted to focus on saying that PCEP actually has the option of being a complete ACTN interface. But if in a deployment, they want to get topology via other means and use PC initiate and report and update and use, say, BGP LS, that's completely fine. And that's what, in fact, what we had it in the hackathon demo. We were using BGP LS as the protocol to learn the topology, but for everything else, use PCEP.
Yeah, so it has a slightly different status to the other two points in that it's not fundamental. And then in the T's working group just before lunch, I heard Daniele talk about PCCC somewhere, and I wonder if, again, is that something that we should include in this applicability statement? Is that also an intrinsic part of ACTN, or is it something else?
I think we need to add text. We cannot leave it hanging. So I think we would have add a section and clearly state where do we lie in this. So do you want me to tell the answer or just handle it in the document?
I'm happy for you to do either way. We maybe.
If you can make it short, yes.
So because I think this question has come up again, so it's better we do clarify this.
Yeah.
So so far as a PCE-based central control, what we should look at first as an architecture, it is just saying that what if we use PCE to control all the devices in the network, use label allocation, management. So at least the extension part is quite limited from child PCE to the network part. But of course, you can have hierarchy. But what happens is when we look at the message exchange that we are thinking that we need for PCCC to work, and the new message being the label management. Label management may feel we never will do it in a hierarchical way. The labels belongs to the domain controller itself. So we don't expect those messages to actually go up and communicate to the parent PCE. So in that model, PCCC is just a part of your ACTN architecture. This child PCE, in fact, could be PCCC. This one could use segment routing. This one can use RSVP. We use PC initiate message
from
MDSC.
It's the PNC's business what it wants to do.
Exactly.
So it could do any applicable PCE within the domain topology. PCC is one way.
Yeah.
All right. Okay, so thanks for that. I guess I'd be interested to know if anyone else thinks this is useful or if it's just good for my education.
I'm cutting the queue after people standing.
Just ensure. So had my reservations about PCIe-LS before. You're missing a lot of stuff available already in AGPs and BGP-LS. You're creating additional complexity because PCIe per definition cannot instantiate any link state, while IGPs can, BGP to some degree can. So now you need to synchronize with two protocols, which could potentially be conflicting, normalize the data, and
so
it's really complicated. Yeah. You don't want to do this.
So I think again, it depends upon how do we want to use it. In the main case that we want to use PCIe-LS is because we are especially if you use PC central control, and you have a PCIe session maybe directly to each of the device, then I'm just going to get the traffic engineering data directly from the device, and I'm not relying only on the local information from the device and bringing things together. That's one mode. Of course, that's not the only mode. We also say there are multiple ways you can actually use it, but that's one of the mode where it is useful. And the problem that you state may not happen. So there are extremes for everything, and I agree with you.
I think
in most cases you would be missing some attributes of links of not available otherwise. And
Jeff is making a good point, I think. For generic functions like topology synchronization, maybe you shouldn't put everything into that document. It's a problem per se. We already have various solutions on the table in the IETF, so it's not ACTN specific. You should maybe focus your document on what is ACTN specific and what PCIe could bring in missing feature for ACTN.
Very good comment. So de-emphasize focus of PCIe-LS and just provide possibilities.
Okay, so I think PCIe-LS is definitely a separate document. We just say, because this was our attempt to bring everything together. That's all. So yes, and nothing is fixed. Yeah. You can use.
It's a zero version. Okay. You were supposed to be the last one standing. Lou, I'm sorry, I cut the queue. I already got young, so I don't want to be unfair.
Paweł Brzozowski from Adva Optical Networking. So actually, I want to echo what Jeff was saying. So not only we have this OSPFT, BGP-LS, right now we have the Young model for TE topology. We already have guys from Google coming saying we want gRPC. Now you have coming saying we want PCIe-LS. And then we have Ross coming saying we have too many protocols. Let's do something about it, right? So I see a slightly disconnect here, right? And do we really need that many? maybe we should just focus on one or two and that's it, right? And even if we do have many, maybe let's just have one model for all of them and then keep them very similar, right?
Yeah, point taken. You may want to come later to send comment because Hero is the next one who's going to present for the 3 coming slots. Thank you, Drew.
So first, hierarchical PC discovery. So hierarchical hierarchical PC architecture described in HPC this RFC. In hierarchical PC, so parent PC have a number of child PCs, and then child PC can be a parent, and then he has a number of child PCs. So in this architecture, we need to discover the relationship between the parent PC and the child PC. So basically, parent PC need to discover each of child PCs, and the child PC need to know its parent. So the information for parent PC to get from child PC is just the ID, domain, and the position. So the position means either imputed child or child as a parent. And then for child PC, you just get an ID of the parent PC. So we give 2 options. So one option is using open messaging, and then with a new TLV. Another one is using notification messaging, also with a new TLV. So these 2 TLV are some kind of equivalent. So correspondingly, we have 2 procedures. One procedure is using open message in the initialization phase. So in this way, if we already have a existing session between 2 PCs, so in order to discover the parent and the child relationship, we need to maybe bring down the session and then bring the session up, and then we can use the open message to discover the relationship between child and the parent. So another procedure is just using notification message with a new TLV. So in this way, we can discover the parent and the child relationship just over existing sessions, so without any interruption. So this is the TLV, new TLV. So just TLV, we have some flag, P flag indicate the parent, and then C flag indicate the child, and then some TLVs for the information, such as domain sub-TLV for a domain, and the ID TLV for PC ID, and maybe some IP address. So this is the details for the TLVs. So domain TLV and ID TLV and the sub IP address sub TLVs. So here is the procedure using open message. So this discovery is driven by the configuration between the child and the parents. So this is not automatic discovery. So here we need a configuration about a parent and child relationship. So here we have a configuration on the parent PC. We configure child. So PCB is configured as a child PCE. So on child PCE, and the PCA is configured as a parent. So with this configuration, so when we have a new session between the A and B, so A as a parent will send the open message with this parent flag and the ID of this PC to PCB. Similarly, B will send A, its parent, with open message with child flag, so this ID and this child domain. So after parent B receives this open message, it will check the configuration with the information in the message. So you will determine that remote B is a child, which is the same as configured. So in this case, the parent relation is determined. That means B is a child of A. So the parent PC A will obtain the information about B's child ID and the child's domain. Similarly, for child PC B, after receiving the information open message, it will check the configuration with the information from the message, and then the check is consistent with configuration. So it determine, I'm a child, A is a parent. So it will get the information about parent PC, is get the ID of the parent PC A. So this gives another extension, another option. We extend a new notification and type and value. So this one just using this extension to carry the information about a child or parent PC. So this is equivalent to the previous one. So the procedure here using notification message, so we can discover over existing sessions. So we have a existing session between A and B, and after configuration, child and parent relationship, those configuration will driven the discovery. So after configuration, parent will send the child the notification message with those informations. So similarly, child will send the notification message with information, child, and then this ID and this domain. So after receive this information, they will check the consistency. So if it's consistent with the configuration, and then the child and the parent relationship is determined. So here we present the message extensions, two options, and then accordingly we have two procedures. And then the question is, do we need extensions, two options, or if we need one, which one is preferred? So any comments and suggestions?
Any comment from the audience? From any contributor to the hierarchical P work, or anyone? No? I have a question for you. Considering I'm a PCE who's the parent for PCC and the child for PCP, I need to be configured with some information about this kind of relationship. If I need to be configured with parent and child parameters with respect to other peers, do I still need to exchange dynamically this information? Because I've been configured with that already. So do I need?
Yeah, that's a good question.
Do I really need some more mechanism for that?
Yeah, that's
It's just a pairing point-to-point relationship.
Yeah, we need, because of the configuration, we need to confirm in the protocol. This just like similar to the BGP peer. So for BGP, we configure remote peer, and then so in the protocol level, we also need to exchange something to confirm, right? Also similar to hello, and then we configure hello, and suppose we have adjacency, but in the protocol level, we need to double confirm or really have the relationship.
Yeah, so as Jonathan is saying, it's no more discovery, it's just configuration checks between peers.
Yes.
And how dynamic do you see it can be? Do you see often a change between a parent-child relationship?
Yeah, dynamic check maybe we can consider, but because this one may have security concerns. For example, dynamic without the configuration. Yeah, that's one option, I think, or consider automatically or dynamically discover the child and the parent relationship. Yeah, we can consider that one. Yeah, that's good.
Okay. If we don't have any other question, I propose to move to your next lot.
Okay, thank you.
While I'm switching the slides, has anyone not signed the blue sheets? One or two? Okay.
So this is about connections and access for hierarchical PCE. So for hierarchical PCE, so parent PCE will build and maintain the domain topologies. So domain topology is a topology which you see a domain as a node or a cloud. And then there's a connections or topologies among these clouds. So more specifically, that means we have connection in the domain connection. And then also we have connections between two domains by a node, which is ABR, area border router. So in addition to these connections, we may also need information about some kind of access point within the domain. We need to be accessed to outside of the domain. So here we propose extensions to pset to let parent PCE to get the information to build and maintain the domain topologies and also get the access points. So for connections, we have inner domain links. So first we talk about the inner domain link. So inner domain link are a little bit special because over inner domain link, we don't have IGP running over it. So that means that some information is not available. For example, we don't have remote router IDs because those neighboring router ID is discovered by IGP. Also, for another case, for multicast link, without IGP, we don't have a pseudo node. That means with no IGP, we'll select those kind of DRs. So here, for this, so for the P2P link in the domain link, so we don't have node IDs. So the information we have is that link type, local IP address, remote IP address, and those are key informations. So for broadcast link, we have a link type, and then we have a local IP address with mask. So this is different from the information we get from a routing protocol. So in addition to that, we have information about the TE links. So for ABR, so ABR, when we're running the OSPF in the domain in the areas, so we have ABRs. So for areas, we may have a child to control or respond for these areas. So this ABR, the child PCE responsible for area need to send the information about this ABR to its parent. So the information for this ABR is simple, just the router ID of this ABR with some indications. So with this information, the parent PCE can build the connections between the areas. So access point. So access point is some kind of address within the domain. So which is, for example, in some domains, we may have some surface. So this surface associated with address. So this address needs to be accessible to outside. So for child PC need to send this address to the parent PCs. So with this information, parent PC will have all the access points from the domains which is responsible by the children PCs. So for those information in the domain link and ABR and access point, we just we propose two options to invest in the extension. So one is use existing notification message, and then we define new NT and NV and some TLVs in the notification object. So another option is we use a new message. This new message I described in the appendix of the draft. So for this extension, I think the extension is simple. So we just new NT and then new NV. One is for updates and another one is for withdrawal. So the TLV is just inter-domain link TLV, route ID TLV, and the access TLV. So this is the very details about each of TLV and sub TLV. So for inter-domain link TLV, so just contains those link sub TLVs. So this link sub TLV contains the information I mentioned in the previous slides. And route ID TLV, so just one route ID TLV contains the route ID. We have some flags. For example, D is for ABR, E is for external ASBR, I is for ID, and then the TLV is for IP address. And then we have new sub TLVs, which is special for multi-access link. So this is contains IP address and a mask. So here we give procedures. One, first let's look at the procedure from a child point of view. So after child PCB discover its parent PCA, so it will send the information send all the information about connections and access for the domain B. For example, for this domain, we have inter-domain link, point-to-point link, inter-domain link, access link, and ADR. So this notification message will contain the route ID TLV, for example here, and then for the P2P link type, local address, remote address, and TE informations. For this multicast broadcast link, we have a TLV, the ID for this one, and then link type. So this is new TLV is a local address with mask and then TE information. So for ABR, so we just have a ID of ABR, and then we have a flag indicated this is ABR. So for new link and the changed connections, we use the same message with the indication of our updates. So for a connection and access down, so we will have a notification object with the indication of withdrawal. So this information, so withdrawal will give the minimal information to identify those links. For example, for this link, if it's down, so we'll have this route ID for this local router, and then the link type, local address, remote IP address. That's all. So for multi-access link, so we just the link type, and then the local IP address and the mask length. That's all. For route ID ABR, we just give the ID for the ABR. So here we can also do have some optimizations. So if one node attaches to multiple link, we may just use one route ID. Those we don't need to have a route ID TLV for every link attached to the same node. So this is the procedure from a parent point of view. So on the parent PCE, so this also has a parent PCE. After receiving those informations, parent PCE just use this information to build the domain topologies and also get the access point from all the domains, child domains. In addition to that, he may store the information for each child. So when that child is done, just remove the information for that child. So as a parent PC is also as a child PC, so the behavior is I have more behaviors. So here, as a child PC, even though he has a lot of domains, so it will hide the domains connection inside inside his child PCs. So he will summarize or abstract all his child domains as one domain. For example, PCE A is a parent also as a child of P. So it will just summarize these all domains with a cloud with connections to outside, So with this summarize, we will get this cloud for PCE A. So this cloud will have 4 connections. This one is corresponding to this one, and this one is corresponding to this one. So that means this PCA just distribute information, distribute the inter-domain link, which is connected to outside domains. So in summary, we presented the connections and access. So the connection includes inter-domain link, ADRs, and access point. We also propose extensions to existing notification messages. And then we give procedures, child PC procedure, parent PC procedure, and the parent as a child PC procedure. So any questions and suggestions?
Any question from the floor?
It's Adrian Farrell. I understand that you've looked into the hierarchical PCE framework document and identified the list of required enhancements and have set about attacking them. But I think some of your material in this slide set is mistaken. In particular, your comments about IGPs not being able to communicate within their own domain properties of entry and exit links. There are RFCs that describe how to do that. I think what you're really talking about here is actually how you build a parent traffic engineering database where the nodes in that database are the domains that are looked after by children, and the links are the connections between those domains. And that's a different thing and a different motivation, which leads you to the same solution. That whole thing may have been surpassed both by BGPLS and by an understanding of how you might deploy this type of network. So the question you need to answer is, does a parent PCE, and therefore a parent network operator, does that operator already know about the topology of child domains and the links between them? And it seems to me that very probably they do, and there is nothing to be learned.
Yeah, I think maybe sometimes they don't. We need some kind of way, easy way. Yeah. So one way maybe they can get those information through some ways. But here we may provide an easy way to let them to get the information.
I have a question. Let's suppose you have a hierarchical PC and it works with this macro topology built of nodes which represent domains, right? So, and let's assume that in a particular domain, you have inter-domain link and you have another inter-domain link, and there is no actually path between them. Okay, so how does the hierarchical PC knows about that?
So I think first we have we need to discover the relationship between the hierarchical PCE. So after discovery the hierarchical PCE, and then the child PCE will send those inter-domain link to parent PCE. So in this way, parent will have all the information about the inter-domain links, and then with those information, the parent will have a domain topology, right?
But domain topology is presented as a single node, right?
Yeah, the domain topology. So from parent point of view, this guy is a cloud or node.
Yeah. So my question is that what if there is no actually inter-domain path between two links? How and I'm doing path computation on the top level topology. How do I know about that?
Yeah, that's a good question. That's
what I'm asking.
That's a we will come. So that's in the domain path computation.
Yeah.
So when we compute the path, and then that path cannot go through.
Yes.
Then we will not compute the path.
Bad luck.
Yeah, we'll get around.
Oh, yeah,
we'll get around.
How do you get around?
So you basically, you report back a problem and it says it's a current bug, basically. I cannot go this way.
Yeah.
Please recompute. And this could go forever, right? It could
Yeah,
be
yeah,
more-
just like
yeah.
depends on the way the past computation algorithm you use, or so if you, for example, you just use Dexter and then Dexter will search and then that path is blocked, cannot go through and will search another path, another way.
Last comment.
Anton Ivanov, Brocade. I will concur with Adrian. This largely duplicates what is already being done by BGPLS. And as an implementer and somebody who has to suffer from writing code for yet another protocol, I'm sorry, there is nothing easy in converging topology from different models and different protocols, which will be the result here.
Yeah,
I think this should be closed.
Yeah, regarding to that one, I read through the BGPLS and PCFLSS. So in that draft, they just have one sentence says that we can use this one to distribute the information from child to parent. That's all. So because for a parent PC to have a domain topology, we need information. What kind of information do we have? So for the ABR, BGPLS, they don't have those information. For access point, they don't have those information. Also, we have procedures. How child PC to distribute what information to parent. So different, so for example, as a child, also as a parent, so the behavior is different. So from parent, if they know his child is a child also as a parent, so the handling is also different. So a protocol extension includes two aspects. One is the data or message, and that's one is procedures. So here, I think we have extension to messages, data, and also procedures. So these two paths is different from what we have in the BGPLS and the PCFLS.
It's different, but it's achieves the same feature. Clearly, you're duplicating existing feature available on all the protocols. So you're the last one, so we let you manage your own time, but this is your last slot. Take care if you have an appointment. It's already 3 for you, so
this one just,
go on.
Are you done? Okay. This one.
Now you may present.
Yeah,
Up to you.
just quick, this one. So for latent PCE, we consider the case. Right now, the architecture just depends on the routing to obtain the PDD, and then we just want to remove this dependency and have a simple, efficient way to build a PDD. So this assume that we have PCC running on every node, and then we don't have IGPA routing running the network. So PCE just send the information attached to the node to the PCE. So this information is same as we talk about. We don't have, because we don't have IGP running, we don't have node ID, link ID. So they just PCE just distribute this information to PCE, and then PCE build the traffic engineer database. So this is the information. We also propose two options. So one is the extension to object notification message, and another one is a new message. So this is the detail of TLVs. So this is the procedures for PCC running on the node in the network. So PCC will send those informations. For example, PCC running on this node, it will send the information about this link connect to the node and then to the PCE. And then for when this session is up, it sends all the link attached to the node. So when link change on a new link, it will also send the updates to the PCE. And then when link is done, it will send withdraw link to the PCE, and the PCE will build and maintain the topologies. So this is the detailed information about on PCE. So procedure of PCE can also be simplified, because for route ID TLV, because PCE and the PCC, we use the session address of PCE as a ID. So in this case, if we have those information, we just don't need a route ID PLV. We just use the link PLV informations. So this is the procedure for PCE. PCE just using the information from PCE build the T topologies. Yeah, that's all. I think at summary, we have simple extensions and then the efficient way, minimum information sent from PCC to PCE, and then with no dependency on the routing protocols. So any questions and suggestions?
Thank you. Open mic.
Adrian Farrell, I think your first slide may have been misleading.
Mm-hmm.
That one, yeah. What you've shown is a fragment of a picture from 4655, where the fragment is actually of the composite node. And the routing protocol shows the exchange between a pair of composite nodes. And what you're really talking about is how you get information from the network to a PCE, which is shown in later pictures in 4655 and is not dependent on a routing protocol, although it can use one. So your later slides then go on really to say that what you're trying to do is retrieve topology information from a network where the network itself is not running a routing protocol.
Yes.
It would have probably saved my poor legs from having to stand here if you had just gone straight into that. And then we could have the debate on, all right, so you have a network that's not running a routing protocol, and you want to retrieve information from the nodes. Is PSEP the right way to do it? Are there perhaps other ways to read configuration and operational data from nodes?
Yeah, great. Yeah, there's a way just using configuration. We can also get the T topology, right? Yes. Yeah, thank you.
Oh, okay. Okay, so that's the end of our agenda. We're finishing 15 minutes early. That's our gift to you. You can get first in line for the cookies. I want to thank all our scribes on the front row. And don't forget the Yang session after the break.
Thank you.
Hi, Yang.
Out of those three things, right? Step HPC, how do you want to proceed? Because it doesn't need any change behavior. So
yeah,
still answer you. DNS association answer you.
Yeah, I don't think there's any extra stuff to do, so we just go for a working group possible soon from talking to the office.
So you know that we have action for what to do. Yeah. Definitely HPC information draft.
Oh, sorry, the statement.
Yeah.
I'm talking about the stateful HPC. Now we have to bring the HPC next step is see if you can get some people to use mailing list.
Okay. Thank you.
Thank you.